All right, let's talk about one of the most incredible and terrifying secret weapons in all of history. For centuries, the Byzantine Empire had this liquid fire, a flame that just would not go out, even on water. It was basically an ancient flamethrower, and it saved their capital city, Constantinople, time and time again. They called it Greek fire, and then it was gone. The formula, the know-how, everything just vanished, leaving behind one of history's most fascinating mysteries.
And that's the big question, right? The one that has kept people guessing for more than 1,000 years. How on earth did a medieval empire create something so advanced that it seemed to just break the rules of nature? Were they using some kind of lost, almost magical ingredient? Or was the secret something else entirely?
I mean, you have to try and imagine the absolute horror of facing this thing. Back then, naval battles were pretty straightforward. You'd ram the other ship, you'd board it, and you'd fight hand-to-hand. But Greek fire, it just changed the entire game. It was a psychological weapon more than anything. This quote nails it. The fire didn't just burn, it clung to ships, it clung to people. It was pure terror, designed to break an enemy's will to fight before the battle had even really started. So yeah, this unquenchable legend wasn't just a scary story sailors told each other. It was a hard strategic fact. Greek fire was the superweapon of its day, and it was absolutely critical in allowing the Byzantine Empire to hang on, often against impossible odds, for hundreds of years. This timeline really tells the whole story of the weapon's life. Its big debut in 674 literally saves the city. It does it again in 717. For centuries, it's the heart of their naval power. They even made portable, handheld versions. But look closely. The date that really matters here isn't 1453 when the city finally fell. No, the mortal wound came much earlier in 1204. That's when the sack of Constantinople basically destroyed the infrastructure needed to make the weapon. By the time 1453 rolls around, Greek fire is already a ghost.
Okay, so let's try to be detectives here. Let's move past the myth and get into the lab to figure out what this liquid fire actually was. Because we're not talking about magic. We're talking about some seriously sophisticated chemistry for the era.
Now, while we don't have the exact classified recipe, modern science has given us a pretty darn good idea of the main ingredients. The base was almost certainly crude oil, or naphtha, which floats, so check. It burns on water. Then you probably add pine resin to make it thick and sticky. That's how you get that clinging effect. Sulfur helps it light up easily and gives off that awful choking smoke. And the real wild card might be quicklime. Why? Because when quicklime hits water, it creates a massive chemical reaction that generates intense heat, making the fire seem even more unstoppable.
But here's the kicker, and this is the most important part. The secret wasn't just in the flammable goo. Frankly, lots of people could mix up sticky stuff that burns. The real Byzantine genius, the thing that made this a true superweapon, was the delivery system. They engineered a complex bronze siphon that could heat the mixture and then shoot it out under pressure. It wasn't just an incendiary bomb. It was a legitimate pre-modern flamethrower.
And that's why focusing on a lost recipe kind of misses the bigger picture. The true secret ingredient of Greek fire wasn't an ingredient at all. It was the whole system.
And just look at what that system involved. You needed a reliable supply line to get crude oil. You needed secret, state-controlled factories to refine it. You needed master craftsmen who could build precision bronze pumps that wouldn't just explode. You needed special warships, reinforced to carry this heavy, dangerous gear. You needed highly trained crews, the siphonurii, who knew how to operate it without burning their own ship to the waterline. And on top of all that, you needed a whole naval strategy built around using it. If any single one of those links in the chain breaks, the whole thing is useless.
You know, there's a modern term for this, a tightly coupled system. It means that when everything is running perfectly, when the empire is rich and stable, the supply lines are secure, the system is incredibly powerful. But that strength is also its biggest weakness. Because everything is so dependent on everything else, it's incredibly fragile. One little break somewhere, and you get total, catastrophic failure.
So this is the great paradox of Greek fire, isn't it? The very things that made it so special, the secrecy, the centralized control, were the exact same things that ultimately doomed it. It was, quite literally, a secret that was kept too well.
Just think about the difference between Greek fire and gunpowder. Greek fire was a closed system, top secret, controlled by just one empire, and built for one very specific purpose. It was powerful, but brittle. Gunpowder, on the other hand, was an open system. The knowledge spread everywhere. Different cultures were constantly playing with it, improving it, finding new uses for it, from cannons to muskets. It was incredibly resilient. When one kingdom fell, it didn't matter. Gunpowder development just kept on going. The fall of Constantinople killed Greek fire for good.
It really all comes down to this choice. As this quote puts it, secrecy can give you a short-term advantage, sure, but it stifles innovation over the long haul. The Byzantines chose to have a monopoly to keep their weapon unique, but in doing so, they also prevented it from ever adopting, evolving, or surviving the eventual collapse of the very empire that created it.
So how did the fire finally go out? It wasn't a single moment. It was a slow, agonizing death by 1,000 cuts. It was the collapse of the entire world that had made it possible in the first place.
The system just started to unravel from every direction. The empire lost land, which cut off its access to crude oil and tax money. The state went broke, so it couldn't afford the crazy expensive ships and factories. Then you get the 1204 sack of the capital, which just smashed the whole production chain to pieces. And while all this is happening, gunpowder is getting better and better, making Greek fire look kind of old-fashioned. And maybe saddest of all, the hands-on knowledge was lost. The skills of the siphonaria oi weren't in a textbook. They were passed down from master to apprentice. With no ships to sail and no battles to fight, that knowledge just evaporated.
And so, by 1453, when Constantinople finally fell, the city's legendary weapon was just that, a legend. The mighty walls weren't brought down by liquid fire. They were brought down by giant cannons, the product of that open, resilient, innovative system that had, in the end, won out over secrecy.
So why are we talking about this? Why does this ancient story matter now? Well, because the story of Greek fire has some pretty powerful, timeless lessons about technology, knowledge, and the societies that build them.
And this, right here, is the biggest takeaway. We get obsessed with this romantic idea of a lost recipe, a secret ingredient written on some dusty old scroll. But that's a fantasy. The truth is so much more profound. The knowledge wasn't a piece of paper. It was a living, breathing system of supply chains, factories, and human expertise. The recipe wasn't lost. The entire world that made that recipe possible just ceased to exist.
And that kind of leaves us with a pretty chilling final thought, doesn't it? Take a look at our own world. Think about the global supply chains, the incredibly specialized factories, the concentrated expertise it takes to make something like a modern semiconductor or to keep our GPS satellites running. Which of our own modern miracles depend on systems that are so complex, so interconnected, so tightly coupled that they could become the Greek fire of some future age? It's definitely something to think about.
The lost system. History often remembers the spectacle. A terrifying, inextinguishable flame that saved the Byzantine Empire from certain destruction. But for centuries, we have been chasing a ghost. We've been looking for a secret recipe, as if it were a simple chemical formula. The truth is far more complex. Greek fire wasn't just a liquid. It was a sophisticated socio-technical system. It required a massive state bureaucracy, specialized supply chains, and engineering far ahead of its time. When the empire finally collapsed, it didn't just lose a weapon. The entire system died with it. The asymmetry of memory. Why is it so hard to recreate today? It's because of the asymmetry of memory. Historical chronicles recorded what they saw. The roaring sound like thunder, the black smoke, and the adhesive liquid that burned on water. This is narrative durability. We remember the event because it was spectacular. But historians discarded the technical data. We lost the mixture ratios, the heating gradients, and the pump tolerances. We know what it did, but because the process was never written down, we cannot reproduce the exact configuration. Chemical plausibility. While the exact ratio is lost, the chemistry is plausible. It was an empirically calibrated mixture of naturally occurring hydrocarbons. The base was likely naphtha or light petroleum, sourced from surface seeps in the Caucasus. To keep it from dispersing in the sea, they added pine resin. This acted as a thickening agent, creating a viscous gel strikingly similar to modern napalm. Finally, sulfur was added as an ignition aid, creating that signature dense, terrifying smoke. The genius wasn't in discovering new elements, but in how they balanced these ingredients. Kinetic projection. The mechanics were just as vital as the chemistry. To project this flame, the Byzantines used a bronze siphon. This wasn't a simple pipe. It was a complex system of swivel-mounted tubes and double-acting force pumps based on ancient pneumatic principles. The mixture had to be preheated in a sealed, pressurized cauldron to reduce its viscosity. This created a massive engineering challenge: the thermal expansion of bronze. To prevent leaks that would incinerate the crew, they used organic gaskets made of leather and wool. It was a masterpiece of medieval engineering. The delivery system. Greek fire wasn't a weapon a soldier could carry. It was a capital ship weapon system. It required a modified fleet architecture centered on the dromon. The foredecks were structurally reinforced to support the immense weight of the bronze siphons and to protect against thermal blowback. Tactical manuals dictated specific echelon formations to concentrate fire on enemy flanks. However, it was a niche weapon. Deployment required strict meteorological awareness. A simple headwind could be fatal to the Byzantine crew itself. The socio-technical matrix. To understand why Greek fire vanished, we have to look at its tight coupling. The system depended on the perfect alignment of four pillars: the imperial bureaucracy for funding, the material resources from the supply chain, the specialized apparatus from the workshops, and the skilled labor of the operators. If even one of these nodes failed, like a supply chain disruption, the entire weapon became inoperable. Unlike simple tools that can survive locally, Greek fire required the full weight and stability of the empire to function. As historians noted, the recipe was the state, the invisible supply chain. The supply chain was massive and invisible. It started with the extraction of crude oil from specific seeps in the Caucasus and Mesopotamia. From there, it moved to fractionation facilities for refining and then to state-funded workshops in Constantinople for chemical mixing and bronze casting. This entire operation relied on the Roman tradition of centralized taxation and logistics, known as the annona. When the empire lost territory in the 11th and 12th centuries, this supply chain fractured and the fire began to dim. Tactical paradigm. How was this weapon used in the heat of battle? It wasn't just about random destruction. It was about force multiplication. Greek fire allowed smaller Byzantine fleets to defeat much larger navies. The weapon was deployed in a projected arc, usually from the prow. By creating a literal wall of fire on the sea, the Byzantines could control the movement of enemy ships, a concept we call area denial. Enemy sailors, knowing the fire could not be extinguished by water, would often abandon ship at the mere sight of the bronze siphons being uncovered. Information security, the secret. You might wonder why no one just stole the recipe. The answer lies in compartmentalized knowledge. The Emperor Constantine Porphyrogenitus famously commanded that the secret must never leave the capital. But the secrecy wasn't just a law, it was built into the system. The chemists didn't know how to build the pumps. The pump builders didn't know how to navigate the ships, and the sailors didn't know the chemical ratios. This institutional siloing meant that even if a single person was captured, they couldn't give away the whole system. The secret wasn't a piece of paper. It was the collaboration of thousands. Systems analysis. To analyze this as a modern engineer would, we see that Greek fire had a very high maintenance ceiling. Every component, from the pressure valves to the fuel tanks, required constant upkeep. This wasn't a weapon you could pull off a shelf after years of storage. It required active state investment and a stable political economy. If the workshops in Constantinople were underfunded for even a decade, the tacit knowledge, the skills passed from master to apprentice by hand, would be lost forever. Knowledge that isn't used dies. Proprietary knowledge versus open source. This brings us to the great transition in warfare. Greek fire was proprietary knowledge, held by one state, guarded by one city. Compare this to gunpowder, which was open source. Gunpowder recipes were simple, scalable, and could be produced by almost any culture with basic chemistry. While Greek fire was technically superior in naval combat for a time, it couldn't compete with the network effect of gunpowder. One was a guarded secret of a dying empire. The other was a global technology that anyone could improve upon. Shift to kinetic energy. By the late medieval period, a massive strategic shift occurred. The move from surface combustion to kinetic energy. Greek fire was optimized for burning wooden hulls. However, as ships became more reinforced and stone fortifications became the primary target, the kinetic penetration of gunpowder artillery became more valuable. It wasn't just that Greek fire was lost. It was superseded by a more robust energy paradigm. Cannons were versatile, they worked on land and sea, and they didn't require a specialized Byzantine bureaucracy to function. The lesson of loss. The final image of our study is the lesson of loss. It shows the total interdependence of technology. You cannot separate a technological artifact from the environment that sustains it. We haven't found the recipe because the recipe wasn't a list of ingredients. It was a process embedded in a specific political economy. Greek fire is a haunting case study in how complex, specialized knowledge can vanish instantly when the institutions that support it fail. It is a warning about the fragility of our own concentrated expertise. The fragility of knowledge. In conclusion, the ancient flamethrower remains a mystery not because its chemistry is beyond our understanding, but because the socio-technical matrix that created it is gone. Innovation requires more than just ingenuity. It requires durability. As you look at the world today, ask yourself, which of our miracle technologies would survive if our global supply chains disappeared tomorrow? The fire of the Byzantines went out because the system that fueled it was broken. Thanks for watching Knowledge World.